Hello everyone, welcome to Primus Learning. It's Aziz here today, and we are going to be looking at Introduction to Cloud Computing, which is going to be the beginning of our AWS Cloud Practitioner course. And in this first chapter, we are going to be discussing about, basically in the whole course, we are going to begin by looking at introduction to traditional IT infrastructure. Then we are going to look at scalability. We are going to look at disadvantages of using data centers, and then we are going to look at colocation data centers. We're going to look at how the various big tech giants like AWS, like Amazon, like Google, like Azure, how they are making use of these colocation concepts to be able to provide us what we know today as cloud computing. Then we're going to look at cloud computing deployment models as well as some cloud terminologies. So this is what we are going to look at in this very, very first section, which is introduction to cloud computing. So to better understand this concept of cloud computing, the best way to go about it is to first understand, understanding the traditional IT infrastructure, how were things working before we had before we had the cloud. So first, let's look at the traditional IT infrastructure and how it usually look like. So say for example, you have a banking solution, right? You have a bank, and you have a new idea. You want to start up a new bank. So you go ahead and then you get up, you get an office space, and then after getting the office space, because remember, whenever you have a bank, you need a banking solution, right? How are you going to be able to manage your customers? How are you going to be able to create your account? Where are you going to store your customer information? Where are you going to store the data? So you need what we call servers. So a server is just like, it's just like a computer system, but it's much more bigger. Okay, and it's used for this type of scenarios, for this type of purpose. So when you get these servers, then you store them in what we call the back office. So you can see here in your bank, you're going to have your servers inside here, and then you have the cashier, and then whenever a customer comes in to do a particular transaction, then they go ahead and send the request to the server that is inside here, and then they're going to do, if it's a deposit or a withdrawal, then they're going to do everything that they're doing inside here. So this is basically how traditional IT infrastructure looks like, and this is called a data center, or what we call private cloud, and we'll see that eventually. This is called a data center. So whenever a company has their own servers within the location of the company, it is basically called on-premise. It's called on-premise. So on-premise or data center or private cloud, basically the same thing. So this is basically how the traditional IT infrastructure looked like. So initially, you start up a company and you don't know exactly how many clients that you're going to have, right? Maybe say for example, this guy that owns this bank is called Kingsley, and Kingsley has decided to start up a new bank that is called Primus Bank. Okay, and then at the very beginning, he assumes that he is just going to have like one client. Okay, but then so he went ahead and then purchased just a single seller, because he thought that he's not going to have many clients and everything is going to be okay. The solution is going to work very well. So, but then just a few days into business, Kingsley then discovers that he's starting to get more and more clients. Like, people are starting to talk about the new banking solution that he's providing, and he's starting to get a lot of traction, and he's starting to get a lot of clients. So what is going to happen? Because Kingsley never provisioned enough IT infrastructure to be able to scale and to be able to contain this number of users that are currently coming in. Kingsley needs to do something about it. Okay. So after some days, so what if Kingsley decides to get more servers? Okay, what if Kingsley decides to get more servers? But as the IT infrastructure is very, very small, and as the customers keep on increasing, he's going to start having issues with the server, because whenever there's a lot of traffic, the server can easily just shut down automatically. So Kingsley needs to look for a way to be able to handle this particular issue. And generally, whenever you have increasing traffic, and services usually become slower if you don't have enough resources to be able to handle all those requests. Okay, so at this point, Kingsley has under provisioned, and definitely either he's going to and there are two ways he can be able to get out of the situation. All right, either he decides to increase the capacity of the existing server, which means basically by scaling it up from maybe 10 CPUs to 20 to maybe 40 gigabytes of memory, or then he can just decide to maybe get buy more servers. Why not? He can just decide to buy more servers to be able to serve all the users. So what if Kingsley decides to increase the capacity of the current running machine, to 20 CPUs and to 50 gigabytes of memory? This is a good solution and it might work just for some time. It's going to work for some time, but after like when the users keep on increasing, because the physical hardware can only be able to, it can only take up to a particular amount of CPU, up to a particular amount of memory, and will no longer be able to, you will no longer be able to scale it up. So whenever you do this, whenever you increase the capacity of a particular server like this, you're basically scaling it up. So the best way to go is for Kinsey to be basically purchase maybe some new servers. So what if Kinsey goes ahead and gets two new servers? Okay, first of all, to get more servers will take a couple of months, right? And he needs to purchase them, and then he needs the engineers that will come and do the various configurations, networking engineers, security engineers. So he needs to it's going to take some time before Kingsley goes into production with these new servers. Okay. And by this time, clients are already complaining. So whenever you're increasing the number of servers, like what we have here is you're basically scaling out. So as the traffic is increasing, you're increasing the number of servers, you're basically scaling out. And we are going to discuss more about scalability in the later chapter. So, but let's look at the various disadvantages of running a data center, also known as a private cloud. So whenever you have your own IT infrastructure you're maintaining in-house, within the company, the very first thing is that you're going to be having a lot of capital expenditure, which means that you're going to have a lot of upfront cost, right? You're going to go and you're going to get these servers, you're going to get a lot of IT infrastructure, you're going to get storages, you're going to get a lot of things. This is basically what we call capital expenditure. So the cap expense means that you're investing upfront, right? You're investing upfront, but you don't know exactly if that particular expenditure is going to give you enough return. So this is the very, very first thing that happens when you're having your own IT infrastructure in-house, when you're running a data center or a private cloud. So the next thing is the cost of maintenance. It's very, very costly to maintain a data center, right? First of all, looking at the amount of engineers that you need to employ. Okay, then you're talking about the cooling system, because as you're receiving a lot of data and you're processing a lot of information, those servers are going to be heating up. So you need a very, very good cooling mechanism. So it's very, very costly to maintain all these data centers. So guessing capacity. So whenever you have your own IT infrastructure, you're always going to be guessing capacity. All right. And usually at the very beginning, either you're going to over provision or you're going to under provision. Right. So either you're going to buy too much capacity because you thought that you're going to have a lot of traffic at the beginning. But at the end of the day, you discover that you have just a little bit of traffic, and then you're going to have a lot of servers that are lying around and you're not basically using them. So then you have over provision. And by under provisioning, it basically means that you went ahead and you bought just a single or two servers, and at the end of the day, you had much more traffic, and these two servers were not able to serve this particular traffic. So you're basically under provisioned. So it's very, very difficult and expensive for you to be able to scale global, because remember, almost every country has their own data regulation, their own data regulation. So if you want to be able to scale, for example, if you had your business in the US today and you wanted to scale and move over to the UK, then you're not going to use the same databases, and everything is not going to be found in the UK, because remember, the compliance rules in the UK or in the EU region is going to recommend that you have all the customers' data should be in the should be in the EU in you should be in the EU region. So what are you going to do? You need to be able you need to get a new office space somewhere in the UK, and you need to set up the infrastructure again from scratch, buy servers and do all these things. So it's very, very difficult for you to scale globally, and we are going to come to discover that it's very, very easy for you to automatically go into global scale when you're dealing with the cloud. So it also takes you time to buy and provision the servers, as we already discussed about. It takes some time for you to buy and provision all the servers and have them in production. So you need to get very, very good data center engineers. You need a lot of networking engineers. You need a cybersecurity team. You need a lot of networking guys, security guys, because you need to make sure that everything is secured end to end, and you need guys that are going to be able to do what they can do best and make sure that your system is functioning as it should basically be functioning. So, in order to like be able to reduce the cost that it takes into running like traditional IT infrastructure and data centers, some companies decided to be going into what we call colocation data centers, and usually it used to work in two ways. So, say for example, you have company A and company B. Company A can go ahead and provision a lot of resource, and then they come and invite company B and say, okay, we have this IT infrastructure that we have. As you're just starting up, you don't really need to buy IT infrastructure. We already have servers around. You can just come in and we're going to rent these our servers to you, and then you're going to use them, and then you can just pay us, as you're using the services. So this is basically what we call a co-location. Or it could also work the other way around, is that two companies can decide to come together, and then they get the IT infrastructure, and then they set it up. And by doing this, they are going to be able to reduce costs. They will be able to reduce some costs, because we are going to be sharing all the costs of maybe the engineer that we're employing, the cost of the physical security, the cooling systems and all the like. So we are going to be able to reduce some costs by using the co-location mechanism. So, and this is basically how the cloud actually evolved. So bigger companies like AWS, like Google, like Microsoft, they then, because they had a lot of IT infrastructure lying around, right? Bigger companies like Amazon, Microsoft, they had a lot of IT infrastructure that was just lying around. So what did they do? They then decided to say that, okay, since we have a lot of IT infrastructure that we are that we are running, we can just be able to invite anyone that is just starting out to be able to come in and then use our IT infrastructure, use our resources, and then you just pay us as you're using the resources. So that was basically the idea that they had in mind. So how is this different from a co-location? The difference is that in a co-location, the client has the ability to go to a data center, and then they can be able to do the changes, do configuration, and do whatever they want. But with what Amazon, Google, and Azure and all the other bigger cloud providers out there are doing, like Alibaba, is that they don't give you access to come to the data center. So you're only accessing your resources over the internet. So you only access the resources over the internet. So, and this is basically how the term cloud computing was basically coined. So bigger companies like Amazon, for example, the example of Amazon, they then what do? They create a website, a web application like aws.amazon.com. And then they will say, okay, if you want some IC resources, you just simply come to aws.amazon.com, and then you tell us exactly what you want. I want two servers. I want them to be of 2 gigabytes of memory. I want them to be of one CPU. And then we are going to just automatically provision the servers for you in our one environment. And then you'll be able to access these servers over the internet. All right. So, and that is basically what it was. So that is why the term cloud computing is basically always generally defined as the on-demand delivery, right? It's the on-demand delivery of IT infrastructure over the internet, because you have the provider which is creating the infrastructure for you, and then you're accessing the infrastructure over the internet. So that is what basically cloud computing is all about. So it gives that kind of abstraction and makes you feel like you don't really know exactly where the resources are, and it just simply in your mind, you're like, it's cloudy because you don't know exactly where these resources are found. That is why it was called cloud computing, and also because it follows the logo of the internet. So that is how the term cloud computing did come about. And usually with the cloud, you can either be paying using a pay as you go pricing model, or at times it cannot actually be a pay as you go pricing model. So usually depends on the particular cloud provider that you're talking about. So generally we have three types of cloud deployment models. So the cloud deployment models are basically the way a particular company might decide to use the cloud. Okay. So if the company has their own IT infrastructure, like we saw before, and they are maintaining their own data center, then generally this is what you call a private cloud. So you have a private cloud, and if the company is using an external provider like Amazon or Azure or GCP, then it's called a public cloud, right? And you have some companies that decide to use both because they have some legacy information. They might decide to use both. Usually in the case of the banking sector, in the case of the medical sector, in the case of government agencies, they have some legacy data that needs to stay on premise, and then they can only keep some particular things in the cloud. So you have generally the public cloud, you have the private cloud, and then you have the hybrid cloud. So, what are the advantages that you're going to gain from actually using a public cloud provider? So, when you move on to the cloud, first thing you're going to do is you're going to trade capital expense for variable expense. So, which means that you're no longer going to be investing upfront capital, but you're going to be paying as you go, right? You're going to be paying as you go. If you need just a single server, you're going to be paying just for a single server. If you need just 20 gigabytes of memory, you're going to pay just for 20 gigabytes of memory. So you're trading the capital expense for the variable expense, because now you're just going to be spending as you're moving along. So the next thing is that you're going to benefit from the massive economies of scale. And what does this mean? This basically just means that with most cloud providers and most cloud services, as the amount of users that are using the resources as they are increasing, most cloud providers are going to reduce the cost of using these services. So you benefit from the massive economics of scale, because the services are becoming cheaper and cheaper within across all cloud platforms. So also you're going to stop guessing the capacity. All right, you're going to stop guessing the capacity. So because now when you're in the cloud, big cloud providers like Amazon, Google, like Azure, they have a lot of IT infrastructure. So no, you can create a lot of servers, you can have a lot of capacity. So and you can automatically scale this capacity. So you stop getting capacity, because if today you started up and you under provisioned, and then tomorrow you receive a lot of traffic, you can automatically scale. Automatically in just a few seconds you can have new servers up and running, and you're going to be able to receive the traffic from your clients, and you have zero downtime. So that is what you get when you're moving to the cloud. You stop getting capacity, and you're no longer under provisioning or over provisioning. If you have the right engineers, you can be able to automatically scale as your traffic is increasing, and automatically scale back down as your traffic is reducing. You also have the increase in speed and agility. So this basically means that there are some type of services that you will not really get very, very fast, and some type of application that you will not get very, very easily when you have your own IT infrastructure. But whenever you move to the cloud, you're able to rapidly create servers faster, you're able to have databases faster. And it's basically just much more easy, because you're able to have all these things within just a few seconds. So you have that increase in speed and agility of all the resources and how you're running your IT infrastructure. So you're also going to stop spending money on running and maintaining data centers, so you can be able to concentrate on maybe the business aspect, and maybe how you can be able to make the application that you're running in your servers, make it much more better, increase the user performance. So instead of spending money on running and maintaining your data center, you want to concentrate on just the business aspect of it. So next, you can be able to go global in a minute, and we'll see this eventually when we discuss about things like the AWS Global infrastructure. You'll see that most cloud providers have data centers distributed all over the world, right? So basically, you can be able to go global just in a couple of minutes. If you had your business that is running in the United States, and you decided to move your business and have a second branch in the UK, it's very, very easy, just by doing a single click, changing your region and moving to the region that is in the EU or in the UK. Then automatically you're already having business there, and you don't need to go ahead and buy upfront capacity and all the like. You're able to go global just in minutes. So we also have what we call the cloud computing models, and this generally just about the services that are provided by various cloud providers. So each and every service that is provided by a particular cloud provider is going to fall under this generally is going to fall under these three different types of cloud computing models. So either is going to be that the cloud provider is giving you infrastructure as a service, or they are going to be providing you platform as a service, or they are going to be providing you software as a service. So whenever you're running your own on-premise environment, you're going to take care of in the servers, as we saw, you're going to take care of the networking, you will take care of the storage, you're going to take care of the servers, virtualization, operating system, middleware, runtime data, and the applications. You're taking care of all these things. But whenever you move to the cloud, depending on the service you're going to be managing just some particular aspects of the server. So if the particular service is an infrastructure as a service, for example, Elastic Compute Cloud in terms of AWS Cloud, so then AWS is going to take charge of the networking, and then they will take charge of the storage management, they'll take charge of the server management, and then virtualization technology. And then you, the client, is going to take charge of the OS, the middleware, the runtime data, and then the and then the application. So generally, this is what is going to happen. You're going to have the server that AWS is going to create for you, the cloud provider, and then they're going to configure these things. They're going to configure the servers, virtualization, storage, CPU, and networking. And then you, the client, you're going to do the configuration for the application, the data, the runtime, the middleware, and for the operating system. So this is what I mean by infrastructure as a service. So they provide you just with the infrastructure, generally just the hardware and some basic software, and then you take care of all the other components to have your application up and running. So with platform as a service, then they go ahead and do some more things. They are going to provide you, in addition to that, they'll provide you the operating system directly, they'll provide you the middleware and then the runtime. And then you, the client, just simply bring your data and your application. And generally in with cloud providers, this services are usually that what we call serverless services, where you, the client, are not responsible for the base operating system and the basic components, and you just bring your application components and you run them in the technology, and automatically you have your application up and running. So this is basically what platform as a service is all about. You bring just your data and your application, and then you're managing, and that is basically all about it. The cloud provider is going to take charge of all the various other aspects of the server. With software as a service, the cloud provider is doing everything for you. The provider of the service is doing everything for you. The only thing that you do is you just come and use the application. That is basically all about it. They do everything for you end to end: networking, CPU configuration, storage, virtualization, the servers, the operating system, the middleware, the runtime, the data, and the applications. And you, as a user, you just simply just come in, create your account, and you start using it. For example, you have the Gmail. The Gmail is a type of a SaaS platform because you don't really do anything. You just come in, you just come in, and then you create your account, and then you just start using the service. You don't do anything. You have also, like any other social media service usually out there, like Instagrams, like the Facebooks, the WhatsApps. They are just SaaS platforms because you basically don't do anything as a client. You just basically just come in and you use this technology. So that is what a software as a service is all about. So lastly, we're going to look at cloud terminologies. So first, you have scalability. So what is scalability? So scalability generally is just the aspect, it's just the aspect of you being able to increase the number of resources as your traffic is increasing. You are able to increase the number of resources as your traffic is increasing. So then elasticity. So with elasticity, unlike scalability, you're able to increase and you're able to reduce the number of resources. So for example, you have just a single server, and as your traffic starts increasing, you increase and you have more servers, and as it starts reducing, you shrink back and you have less servers. And whenever it comes to elasticity, you have two types. Generally you can either scale up, or you can scale down, or you can scale out, or you can scale in. So when you're scaling up, it means that you're taking the same server and then you're increasing just the capacity. As we saw initially, you increase just the capacity. And by scaling down, it means that you're reducing the capacity of that single virtual machine. And by scaling out, it means that you increase the number of servers, you increase the number of servers. And then by scaling in, it means that you reduce the number of servers. In other words, scaling up and scaling down is also called vertical scalability. And then scaling out and scaling in is called horizontal scalability. So then you have fault tolerance. For fault tolerance, which is basically the ability of us being able to withstand a certain amount of failure and still remain functional. And we are going to be able to understand fault tolerance and self healing systems. You need to understand very well the global infrastructure of most cloud providers, because cloud providers have a lot of data centers distributed all over the world. They can be able to provide you with fault tolerance, which means that if you do design the architecture of your application very well, then if in case something happens to your application in one of the data centers, you can automatically fail over to a different data center. So fault tolerance is that ability. So when you're designing your IT infrastructure in the cloud, you always need to make sure that you factor in fault tolerance. So then you have high availability. Your infrastructure needs to be highly available. By high availability, we just simply mean that you need to make sure all your infrastructure is deployed in as many data centers as possible, so that you can be able to, your clients can always be able to have access to the system whenever whenever they want to. So you need to make sure that there's no single point of failure. So if you don't have a single point of failure, then definitely your IT infrastructure is going to be highly available. These concepts of scalability, elasticity are going to be talked about in more detail when we dive deep into the cloud, and we're looking at cloud services like AWS or EC2 instances. So without further ado, if you liked the video, please don't forget to subscribe and also add a comment if you have any question, and we are definitely going to reach out to you. And I'll see you guys in the next lecture, where we're going to begin talking about introduction to AWS cloud and the AWS global infrastructure.